Welcome to Chem Mastery with Dr. Z. In this video, we are going to talk about exothermic and endothermic reactions. So, reaction energy change. When a chemical reaction occurs, there is always a change in energy between reactants and products. Because chemicals store energy in them, and when reaction takes place, there is always a difference in the energy between the reactants and the products. So there are two possibilities. The first one is if you have reactants energy represented here by this star. So this is the reactant energy, and then the reaction occur, and then you have the product energy. You can notice here that the energy of the products is less than the energy of the reactants. Then that means that some energy was given off to the environment in order to have less energy for the products. If we represent the energy of the reactants by X kilojoule and then the total energy given off by Y kilojoule, then the energy of the product is Z. We will notice that the energy of the reactant will equal the energy that was given off plus the energy of the products. So that means that energy is conserved, which means that it's not destroyed or created. It just moves around. So the other case is when the reactant energy, then the reaction takes place, and then you have the product energy. In this case, this is the opposite. You can notice that the energy of the product is higher than the energy of the reactant. Then energy must be taken in from the surrounding or must be taken in so that the energy of the product can be higher than the energy of the reactant. If we represent the energy of reactant by X, energy taken in by Y, and energy of the product by Z, then X, which is the energy of the reactants plus the energy taken in, will equal the energy of the product. Again, this is because energy is not destroyed or created, it's just conserved, it moves around. So this is called the law of conservation of energy. So let's have a closer look at these two types of energy, two types of energy change during reaction. So the first case we talked about when the energy of the reactant is higher than the energy of the products. This type of reaction is called exothermic reaction. It's exothermic reaction because energy is given off in form of heat to the surrounding, and you can notice this by an increase in the temperature of the reaction. So there will be a rise in the temperature. This is called exothermic reaction. There are some examples of exothermic reactions like fuel burning. So this will give energy. So this is an exothermic reaction. Also, we have the neutralization reaction where in neutralization reaction, this is the reaction between acids and alkali. Also, it gives heat. So this is exothermic reaction. And finally, many oxidation reactions are also exothermic reactions. For example, adding sodium to water will give energy because oxidation of sodium here is an exothermic reaction. So are there any application and uses for these type of reactions? There are several. So for some of the examples are the hand warmers that we use. So hand warmers use exothermic oxidation of iron and air to release energy. So you can use them to warm your hands. Also the self-heating cans of chocolate and coffee, they also use a certain type of exothermic reaction between chemicals in their base, so they release heat that can be used for self-heating. The other type of reaction where the other condition where you have the reactant energy is less than the product energy. In this case, you're going to find that energy must be taken in from the surrounding. And this is called endothermic reaction. So the first one is exothermic, and this is the endothermic reaction. So energy must be supplied from the surrounding. And there will be a reduction or a fall in temperature and you can see that the reaction vessel might be a bit cooler. So this is called the endothermic reaction. Some examples of endothermic reaction is the reaction between citric acid and sodium hydrogen carbonate, and also the thermal decomposition of carbonates like calcium carbonate. So calcium carbonate needs heat in order to give you the products, which are carbon dioxide and calcium oxide. And this is a type of endothermic reaction where energy must be taken in from the surrounding. Are there any applications and uses for this one? Yes, there are. So the sport energy bags. The endothermic reaction allows the bag to be instantly cooler without the need to put them in freezers to get them cold. So there are two types of reaction, endothermic and exothermic. Exothermic reaction, heat is given off in the surrounding. Endothermic, heat is given in from the surrounding.